And is automation sort of a net positive or net negative for environmental impact and how life science is done?
Oh, goodness. It's a good question. As to the last part, net positive, net negative, it's hard to wrap your head around. And I think from where I sit, where especially during development of any kind of automated process, you are just burning through plastic at a rate that feels pretty absurd if you're someone who does care about sustainability and waste. This is something that's been always true of the sciences. So pipette tips are plastic. Generally, they are not really reusable. And attempts at reusing them is likely to make your process less effective, potentially introduce contamination. I'm oversimplifying, but these are generally the problems we worry about, which means you're going through several boxes of tips maybe per day, depending on what you're doing. I've definitely been, again, on the bench sitting next to more senior folks who have a stack of empty tip boxes, 10 high, and that's just, today's work. And then there's all the plates you're using, right? Whether you're using tubes on the bench or you're using plates, all of this is, and again, that's just looking at the plastic waste. It's not looking at the reagent waste and potential biohazards. It is something that feels really tricky, and I know a lot of folks in the industry are very aware of. I feel like every year I hear a new conversation about, like, have we figured out a better solution for this? And there are some. So there is a company, Granova, that makes a tip and plate, like, washing system. So you can now automate the washing of your plastics if you want to reuse them. And they've been around a long time and they have great success stories. There are definitely limits to it. One is very simple and practical. Most of these sciences, you want to use tips with filters in them because that's going to reduce contamination, both of your samples and also of your equipment. If you have a pipette or a liquid handler that sucks up some cells or some DNA, and then for the next month you're running processes that are contaminated, that is creating its own kind of waste, right? It's very tough to wrap your head around, and I'm sure someone else has thought about this a lot more. There are also other solutions like reusable tips. So you can buy heads for some liquid handlers that are made out of metal, and you can do pipetting on that, and then they might have on-deck washing. So, and even like potentially, I don't know if they're called, but you'll see like a little flame shoot up and it'll like really decontaminate those heads. So there are solutions to this effect, but they tend to have limits in their applications. And I think that honestly circles back to the challenges we work with in automation in general, where there's a ton of products out there, there's a ton of solutions out there, there's a ton of options, and every little bit of science is going to have different factors you have to consider and optimize for. And sustainability can be one of those, and especially when you have a lab that's reached a point of more maturity where they're not kind of developing their processes for the first time, and they can take the time to now increase efficiency, decrease waste, et cetera, et cetera. That's sort of the stage when you get to worry about these things, and it's a lot more challenging for folks who are in earlier stages of development, or they're building out their lab at a startup for the first time, to consider. So it is tricky. Not one solution for sure.
Yeah, and at that stage of maturity too, you can start to think about assay miniaturization, which does actually cut down on all of these things. And depending on the type of automation that you might be using for something like this, you might be able to go tipless if you use some acoustic liquid handler or something that has a reusable cassette of some kind. So there are definitely ways to go in that direction. Depending on where you are in your process and your growth.